All right, so today we're going to be talking about geometric mean. Now, geometric mean is different than the mean that you guys are used to hearing. Uh, the mean that you guys have come to know as mean is when we take a data set and we add up all those numbers together and then divide by the total number of data sets that are in or data values that are in that set. Right? But geometric mean is a little bit different because geometric mean is primarily used to analyze data sets that involve multiplicative relationships. So notice when we're just finding mean, we're just adding up all those numbers. So that's an additive relationship, whereas the geometric mean, we're finding the multiplicative relationship. So the geometric mean of two positive numbers, a and b, is the positive number x such that a over x is equal to x over b. Now, this geometric mean is used for tons of different things, right? Finance, investments, um, medicine, a lot of different things use this. And so they use this setup, this proportion. And so if I wanted to actually find what the geometric mean of those two positive numbers would be, what would the process be? What would I do first right here with my ratio is equal to another ratio, my proportion, right? Good, good. We would cross multiply, right? So x times x is going to be x squared, and then a times b is just going to be ab, right? And if I wanted to get x by itself, what would I do? Awesome. Yeah, I would square root on both sides to cancel out that square. And so all I'm left with is x is equal to the square root of a over b. Well, let's see what this would look like in action, right? So if I take 6 and 30, for instance, and I set it up where 6 is a and 30 is b, then I would have that set up like 6 over x is equal to x over 30, right? So the setup doesn't change. We're just plugging in those numbers into those spaces, right? Okay. All we're going to do, right? Cross multiply, butterfly method, right? So x times x is going to be x squared. 6 times 30, if we don't know, we can plug it into our calculator, is going to be 180. And then what do we do last? Great. Good. Square root, right? So cancel out, and we're left with x is equal to the square root of 180, which if we plug into our calculator comes out to 13.42. Okay, go ahead and take a minute and a half, and I want you guys to just try out number 6. Great, now that you've gotten the chance to try out number 6, your setup should have looked something like this, which I saw that on a lot of your guys' papers. Now, Jimmy, what did you do after we set this up? Perfect. Cross multiplied, right? And so we got x squared is equal to what? 448? Okay. Perfect. Yep. And then we're gonna, exactly, square root on both sides, right? Cancel, cancel. All that you're left with is x is equal to square root of 448, which is going to be 21.17, rounded to the nearest hundredth. Now, you might be thinking to yourself, man, this seems really easy. Well, it is going to get a little bit tougher because now, instead of just looking at numbers, right, we're going to look at right triangles. And more specifically, we're going to look at essentially like a right triangle side of a right triangle with this example right here. So the geometric mean theorem, where we have altitude, remember this altitude word refers to the shortest distance from our right angle of this big triangle to the hypotenuse. So like the altitude for this triangle over here, right, would be this distance right here. It'd be somewhere along right here, right? So it makes like a 90 degree like that. Or if we did over here, it'd be something like that. So we're referring to this big overarching triangle right now. So this would be our altitude, B to D. So our theorem states that the length of the altitude is the geometric mean of the lengths of the two segments. So the altitude is the geometric mean. Well, up here we were saying x was the geometric mean. And so we set up our formula with x in the top and x in the bottom like so. And then we had a positive number a and a positive number b. Well, couldn't I replace that a and b with the lengths of the two segments, which are AD and DC? So something like this, AD over, we'll leave that blank for now, and then DC in the denominator. And then if BD is our geometric mean, well, didn't we say X was our geometric mean? So let's replace X with BD. Well, what do you notice here? Essentially, this thing creates a kind of shape, if you will. It goes from A to D, up to BD, back down from BD, and then through to DC. Maybe you've seen this shape before. It kind of looks like yeah, exactly. It kind of looks like a heartbeat, right? If you've ever been to like a hospital or seen a show with some medicine or something, doctors, right? You've seen that heartbeat probably before. So what we're going to do with that heartbeat is we can use that to procedurally set up these problems. So if you look at problem number 8, right? Problem number 8 isn't as nice. It's not as like nicely set up as the one that we just did. But if I take this shape and I simply rotate it, well, then I can see it as my shape. So 12 is going to go from here to here, right? 8 would then go over to here, and then X would be right here. And once again, we can see that heartbeat right through the middle. So again, although you guys can't rotate images like I just did, you can simply rotate your paper, guys. Yeah. So does everybody see that? Perfect. Perfect. So when we do that, we can now do our setup, right? So our setup says we're going to go 12 first, then up through X, back down, and through. So let's do that slowly, one by one. So we go 12 over, right? That's our first. Then we're going to go up by X. We're going to go back down X. And then we're going to go through 8. Perfect. So there's our setup. And now all we have to do, cross multiply, right? So x squared is equal to 8 times 12, which is 96. And then square root on both sides. And the square root of 96 comes out to, I believe, 9.80, rounded to the nearest hundred. All right, now I want you guys to try out number 9, but I also want to point out that on number 9, you're given this length, which is the whole length. Remember, we only want this length right here. So how would you find that length? Yeah, how did you get 32? Exactly, right? This is the whole length, and then we have this 5 up here. So if I take away 5 from 37, I'm going to get 32. Perfect. Go ahead and try out number 9.